Guys, this is Brian. I've had a couple of requests to do a demo at my house where all of the data was extracted for the actual design guide. So now I'm going to take you through and actually show you kind of like the process I went through as well as the data. So here we go. So first we have the design here. You can see the board. Unfortunately right now I don't have the actual UART to USB that I had in the lab. So right now we have a secondary device that we're using to relay the information wirelessly to my other laptop, which has the UART connection. You can also see here we have the wires. This right here, as you can see from the design guide, that is the piezoelectric sensor that we're using on the blower. This one right here is the one that's in the filter. Currently we have the motor running. So now it's time to do our test. So if you look over here, we have this right here is unfiltered data, so it's actually a lot smoother when it goes through the MSP430. Now on the software we do have implementation for a probability counter. This allows us to disregard points like this to where it briefly dips down before it comes back up. So you know, once hitting this point, you know, if I don't hit that point consecutively over a certain amount of time, in this case 5 seconds, then I go ahead and just disregard that data and assume that we're still in the preferred operating range. So now what we're going to do is we're actually going to take this paper and we're going to stick it up here on the vent to simulate a clogged filter, and then we'll watch the values drop. Stick it up here like this, and then as you can see there, the value drops very, very dramatically. It's a pretty significant discontinuity there, and as you can see, the value is staying around you know, probably 20 to 25, not really getting out of that range. So our threshold over here would have been set probably somewhere around maybe 170, 180. So this is definitely, you know, significantly lower than half. So, you know, this would definitely trigger the system. So now let's try the exact opposite. Let's go ahead and take the papers off and watch the actual value rise back up to where it was before. And as you can see right there, it's going to shoot right back up to pretty much where it left off at over here. Like I said, the discontinuities here that you see, the pretty high amplitude differential signal that you see right there is mostly due to the fact that we've got a differential piezoelectric sensor in this HVAC system, and we haven't actually done any of the mathematical signal conditioning that we do on these, but in any case, this still works perfectly